Okay, so no power at the thermostat. So let's go see what's going on with that. All right, so power's on. We're gonna check that it's three-phase power coming in. So blue, yellow, black, these are the main three legs of power. So 1 and 2, 212, 1 and 3, 212, 2 and 3, 212. All right, so we got power coming in. I'm gonna check the red terminal on the board. This is power going down to the thermostat. We got nothing. We have no red light right here, which means we don't have power coming in to the unit. The transformer creates our 24 volts. So what I'm gonna do is we're gonna check the power coming into the transformer. See if we can do this one-handed here. Actually, let's do this. You can see that. Let's do that, better for you. All right, so this should be 210, yep. Right, is it creating its 24 volts? Yes, it is creating its 24 volts. All right, so here's the red line coming out of the transformer into the board, 24 volts. And then the other side, after the 24 volts is done and gets proven, nothing. So we don't have a complete circuit here for some reason. We cheated a little bit. So on all these red lines, these are all powers, right? So on the number 3, right, that's where it's coming in. We got 24 volts. So let's go to number 1. We got 24 volts. Let's go to number 2. We do not have 24 volts. Okay, so to our favorite, the wiring schematics. All right. So here's the 24 volt transformer. It came into 1, 2, 3, number 3. So we knew we had power there. We knew we had power on number 1. Number 1 goes up and runs into the IFM. That's the indoor fan motor. That's the blower motor. And then it runs out of that motor. So we've had this problem before where the wire rubbed out, which is why we've got it all wrapped up, where it's three-phase power. So the black and yellow and the blue is the power to this. And then these two red lines, this is 24 volt proving. So either this motor, it's designed that if the motor melts down, that shuts down the unit. So we know for certain power is going into the motor and power is not coming out. So here's what I'm gonna do, given that it's 24 volts here. We're gonna take this and I'm gonna jump from the first red, which I had my power, okay? And again, this is 24 volts. You cannot do this if it's 120 volts or anything real. I'm gonna tell the fan, I'm bypassing the fan now. Take a look here, red light. 24 volts going to the thermostat. So the thermostat's waking up right now. So it's going to wake up, assess the temperature, and it's gonna start running. We can't keep this jumped like this. So now we have to chase these red wires back and determine, is it the internals of the fan that have failed, or is there another rub in this wire somewhere? To be continued on that one. So in further diagnosing, trying to find out whether the problem is in a broken line or the problem is in the motor itself, you can see we have cut the 24 volt leads out of the motor and I've jumped them together so that if the wire was broken, it's not going to matter. It's still not going to get its signal back. But if it starts, then we know the problem was inside the motor since I cut it so close to the motor. So it's been set up for a second, but let's see if we can test it with the meter here. I believe it was 1 and 2. Let's see if we can't put this in here. Let that be my ground. So number 1, 24 volts. And signal back, number 2, 24 volts. Which means we have 24 volts going down to red. And since it's cooling, it is Y1. Okay, so the problem is definitely in the motor. Now the question is it failed? Has it failed on purpose? Is that motor failing inside, or is it just gone faulty? We're gonna go ahead and amp it out and see. Sound's gonna get funny, but I'm gonna show you the amps on this. So that shows you that it should be amping at 204 volts at 7.5. I'll show you again right here. So we're allowed to amp at 7.5. We're gonna take this cover. I'm gonna put the cover back on. I'll take the meter. We're gonna switch to amps. 6.4 amps, 6.5 amps. We're running perfect. That motor's not stressed. So the interrupt inside has failed. Incorrectly failed. So, all right. I'm going to consult someone wiser than I, but I can tell you that 24 volt meltdown safety is not on every motor. It's a very optional thing. So I'm more than likely to just cap those wires and call it a day. If the motor melts down, the motor melts down. It's still gonna trip the 24 amp, or it's gonna actually blow the fuse on the heater board or something. So that's that.